All right, 12.4 is probability of disjoint and overlapping events. So it's similar to like independent when it's disjoint and it's, and it's overlapping, except that these are going to be like an or statement. You're trying to get this or that. Whereas up to this point, we've done and statements. You're trying to get this and that, right? So now you have to pay attention to things like the words or and, okay? And it may not always be those exact words, but it would say something like both, and a both would be an and, okay? Whereas it's when you're saying or, like I'm trying to pull a club or a 10. And those things would be one pull, and you're trying to get two different things, either of those two different things. Those are or statements. So we're going to start to pay attention a lot to the wording of these questions. So the compound events are when you've got, again, two different events. So they call these A and B. And the union of them is a compound event. So if A and B can overlap, then it causes what's called a compound event. So those are Venn diagrams. If you know what a Venn diagram is. The union of A and B is where they would overlap. So all of that's blue. The intersection of A and B is like the and. Where is it both A and B? So union is either A or B. So it would be any of that. That's why it's all blue. Whereas the intersection is where they would overlap. If A and B are not, so this is where the overlapping occurs. If they do not overlap, then they can never have an overlapping section, and then it would result in where they're completely separate. So if you think about this in terms of like a deck of cards, okay? Two completely separate things could be like a red card and a black card. One card can never be both, right? You can't pull a card out of a deck and have it be both red and black. Does that make sense? So those are called disjoint or mutually exclusive. It cannot be both. Whereas a black card that is a face card can be both, right? There are face cards that are the color black. Does that make sense? Can you pull a card out of a deck that is the color black that also is a face card? No. Yes. So those are overlapping events, okay? So that's the difference between overlapping and disjoint or mutually exclusive, okay? Overlapping is also called mutually inclusive, but your book says overlapping. So that would be something like this, okay? Where on the left could be all the black cards, and on the right is all the face cards, and the overlap is in between.
What will it get in between? Both?
Correct. So if I said even and odd card, are those mutually exclusive or disjoint or overlapping? Even and odd. They'd be exclusive or disjoint, right? Something cannot be both even and odd. Yes? Okay, if I say less than 5 and even, less than 5 and even would be? Overlapping, because there are things that are less than 5 that are also even. Does that make sense?
Yes. Be the middle one?
That would be the middle one. Yep. All right, so the probability of compound events are found these ways. If they are overlapping, which is this first one, so this is overlapping, then I find the probability of A, notice the word there is or B, by doing the probability of A plus, now we're not multiplying, we're adding, plus the probability of B minus the probability of A and B. And then for disjoint events, so ones that do not overlap, found it, good. Then the probability of A or B is the separate, just added them together. Probability of A plus the probability of B. So the first question on any of these is it and or? If it's and, we have to worry about independent, and we would multiply. If it's or, we have to worry about disjoint or overlapping, and then we add.
I don't get how it has like a word inside the thing, inside the parentheses.
Well, you'd have to find the probability of both A and B happening. That's what that means. Or, so you want a red, what's the probability of getting a red card or a 10? Like that. So it's one pull. And it's this or that. All right, so it says a 6-sided die is rolled. Find each probability. A, the probability that the number rolled is less than 3 or greater than 5. So the first thing you want to identify is or, right? Because that means we're going to be adding here. Or, add, and multiply. Now, if it's an or, we have to figure out, is this disjoint or overlapping? So can a number rolled be less than 3 and also greater than 5? No. So this is disjoint. And in disjoint, we just find the probability of the first one. So probability that it's less than 3. And we add to it the probability that it's greater than 5. So less than 3, how many options on the die would be less than 3? 2 out of how many sides? 6. And greater than 5? 1 out of, again, 6. So this becomes 3/6 or 1/2. If you actually consider all of the options here, 1, 2, 3, 4, 5, 6, and you want something that is less than 3 or greater than 5, you would also get 3/6 or 1/2. It is not bad to do that with a 6-sided option. It is way worse to do that with a deck of cards. Like, you don't want to have to count all the deck of cards. Does that make sense? You want to use these formulas. Okay. B, the probability of rolling a number greater than 4 or even. So again, or, which means we're going to add. And now greater than 4, even. Are those mutually exclusive? I'm sorry. Are those disjoint or overlapping? They are overlapping because a number can both be greater than 4 and even. So we're going to find the probability that it's greater than 4. We're going to add to it the probability that it's even. And we're going to subtract from it the probability that it is greater than 4 and even. So what's the probability it's greater than 4? It'd be 5 or 6, so 2, right? 2 out of 6. What's the probability that it's even? 3 out of 6, 2, 4, 6, right? So 3 out of 6. And what is the probability that it is greater than 4 and even?
2 out of 6.
What number is greater than 4 and even?
6.
Just 6. So it's 1 out of 6.
It's not including 4.
Correct, because it's greater than, not greater than, or equal to.
Okay.
So I'd get 5 minus 1 or 4/6, which is 2/3. And again, I could have looked at my set and I could have found anything that's greater than 4, which is 5 and 6, and also even, which is 2. That's 3 out of the 6. No, wait, greater than 4 or even, sorry. And that would have resulted in the same thing. Because 4 would be even and 5 and 6. 2 and 4 would be even and 5 and 6 would be greater than 4. Yeah. Because it can't be both less than 3 and greater than 5. So that one's disjoint. If it's disjoint, you don't have to worry about subtracting the overlap.
Is this the only two
All right, so we talked about the importance of knowing our standard deck of 52 cards. Here it is again. 4 suits, clubs, spades, hearts, and diamonds. There are face cards that are jacks, queens, and kings. There's 13 cards in each suit. Ace, 2, there's no 1. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. The clubs and the spades are the black suits. The hearts and the diamonds are the red suits. This, you have to understand the deck of cards because it's just going to ask you questions based on it. And obviously, if you don't know a deck of cards, you won't be able to answer them. Yeah. All right. This one says a card is randomly selected from a standard deck of 52 cards. Find the probability of the event. A, selecting a face card a 5 or a face card. So again, it's or, right? Which means adding. Can it be both 5 and a face card? Disjoint, okay? So I'm going to do the probability of the 5 plus the probability of the face card. How many 5s? 4 out of 52. How many face cards? 12. There are 4 kings, 4 queens, 4 jacks. So, I mean, I would say if they both reduce, I give you the same denominator. You could reduce them, but be careful because if they don't, you don't want to have to then find a least common denominator. So you could either add and then reduce, or again, reduce, as long as it's going to give you the same denominator. What goes into both 16 and 52? 2 goes in there, 8 and 26. And then from there, 2 again, 4 and 13. Oh, that's hard to read.
Don't we have to subtract?
There's no overlap because it's disjoint. If it's disjoint, you don't have to subtract.
Two more. You good?
All right, B, selecting a face card or a diamond. Can it be both a face card and a diamond?
Yeah.
Yes, this time it's overlapping. So I have to do the probability of the face card plus the probability of the diamond minus the probability of the face card that is also a diamond.
I have a question.
Yeah,
What is that?
it's a diamond. I knew you were going to ask that. What's the probability of picking a face card? We just said how many face cards are there? 12. 12 out of 52. How many diamonds are there? 13 out of 52. And how many face cards are diamonds? 3. Sure. So this is 25 minus 3, which is 22 over 52, which becomes 11 over 26. So are they mutually exclusive or, sorry, are they disjoint or overlapping? Can it be both an ace and a 9?
It cannot.
Cannot, so disjoint. Good, so probability of it being a 9, or let's start with ace, plus probability of it being a 9. What's the probability of it being an ace? 4 out of 52. How about a 9? 4 out of 52.
Equals 8 over 52.
Which equals,
5 to 2 over 32.
good. Questions on that one? Okay, good. 10 and a diamond, possible for it to be both? Yes. Okay, so I have to do the probability, it's a 10, plus probability, it's a diamond, minus probability that it's 10 and a diamond. So what's the probability that it's 10? 4 out of 52. How about diamond?
13.
Good. And diamond 10?
1. 52.
Good. So this is 17 minus 1, 16 over 52. Or 4 13ths. Yep. Because when it's overlapping, you have to subtract the possibility that it's both.
So overlapping means that it could be both.
Correct. Yep. The probability of owning either a car or a computer is given, right? So if you have probability of car or computer equals the probability of having a car plus the probability of having a computer minus the probability of having both. So that's what you're trying to find. Like, what's the probability that they have both a car and a computer? So the or is 92 out of 100. The probability of having the car is 65 out of 100. The computer is 82 out of 100 minus, and that's what we don't know. So if I combine these together, 65 plus 82, that's 147 out of 100 equals 92 over 100. Subtract the 147. And you get negative 55 over 100 equals negative x. So 55 out of 100 would have both the car and the computer. That's like 6. Does that make sense? 7. No, we did 7 already. Oh, no, you're right. I'm sorry. That's like number 7. Except it's trees. But you got to use this. Like, figure out what they're giving you and figure out what you're looking at based on your overlapping, because they can have both. So just, okay, this one says a company is focus testing this is the last one, a new type of fruit drink. The focus group is 47% male. Of the responses, 40% of the males and 54% of the females said they would buy the drink. what's the probability that a randomly selected person would buy the drink? So you have to work, there's two things happening here. The first is how much are male and female. So from my original focus group of 47% are males, which means how many would be female?
53.
47 would be male. That's a really hard color to read, sorry. And female, 53. Or 0.47 and 0.53 in decimal format. Then, from the responses, 40% of the males and 54% of the females said they would buy it. So of this, 40% said yes. And of this, 54 said yes. So you're trying to figure out two things. One, an and statement in between them. So the probability that it's a male and they say yes. So if it's an and, we do what? Multiply. So 0.47 times 0.4 is what we're going to do there. The probability that it's female and they say yes, 0.53 times 0.54. And then the probability that they would buy it would be either the males that say yes or the females that say yes. So after we get these two, we're going to add them together. So this is an and an or built in together. The and come from male and says yes, then female and says yes, and the or is any of them, which means we're going to add them together. So 0.47 times 0.4, and I get 0.188. 0.53 times 0.54, and I get 0.2862. And I add them together. And I get 0.4742. And it says, no, it doesn't say. It wants it in percent. I think it's a whole number. It says decimal? Oh, maybe it'll take both answers. Okay. Yeah, because it says 47.42%. So you could probably have done both.
I got it wrong.
How did you type it in?
Oh, it's a percent?